Okay, geometry fans, our topic for the day, this is section 2-8, slopes of lines, parallel versus perpendicular lines. So our objectives today, after this lesson, students should be able to calculate the slope of a line from 2 points, an equation or a graph. Okay, this is going to be a review for you, but also state and use the relationships of the slopes of parallel and perpendicular lines to solve problems. Before we start, let me give you your joke of the day. Why did the skeleton hit the party solo? And the answer is he had nobody to go with him. Nobody. All right, so the first thing we'll do is a review of calculating slope. And at some time you may have been told slope, we use lowercase m, is equal to the rise over the run. When you think of that rise and run, I'm also going to talk about the rate of change. Slope is about how a line is changing, how something is changing. And it's the change vertically, which is your rise. It's your change up and down divided by your change left and right. That's how we talk about it. So when we say rise over run, it's the change vertically divided by the change horizontally. That's how we set it up. So in number 1 here, it says calculate the slope of each line by counting the rise over the run. In number 1, we have 2 lines. Now for line A, I go from left to right. So I start with the point on the left. I'm going to start here. Now rise means up and down. In this case, I'm going to go down, and then I'm going to go right. Now when I count this, up is positive, down is negative. Right is positive, left is negative. Okay, so we're going to go down. So starting here, I'm going to count 1, 2, 3, 4, 5, 6. Down 6 is -6, and then we're going to run 1, 2, 3 to the right, which is positive. So for line A, our slope is -6 over 3, but you always have to reduce fractions. So that actually just becomes -2 over 1, or you can say -2. For line B, so this time, line B, from left to right, it's going up, so this will be a positive slope. Now I always start, again, the point on the left, we're going to rise, we're going to go up 1, 2, 3, which is positive, and then we're going to run to the right 1, 2, 3, 4, which is also positive. When I count, the point is not 1. It's when I first make my move. So 1, 2, 3. And then from here, this is not 1, it's when I first move. 1, 2, 3, 4. So the slope is 3 over 4. Okay, so the rate of change. How are we changing up and down over how do we change left and right? Now, in number 2, line C and line D, these are special cases. I'm going to start, in this case, actually with line D, which is horizontal. A horizontal line always has a 0 slope. Because if I count, if I pick 2 points on here, the rise is 0. We don't move up or down, but the run is +3. So if I take 0 over 3, 0 divided by anything is always 0. For line C, though, which is a vertical line, this time, if I choose 2 points again, this time my rise, I would go down 3, and actually it doesn't matter which point. Let's say I start down here. I would go up 3, but then my run, I would not move left or right because I'm on the line. So it would be 0, but you cannot divide by 0. That is always undefined. So a way that you can remember this, it's called Hoy-Vux. You may have seen this before. Hoy-Vux. H is for horizontal. Okay, so that's a line that just goes left to right. The O is the slope, so m equals 0. And then the y is the equation. y equals a number. So for line D, the equation would be y equals 2. Every point on here has the same y value. So this line is y equals 2. Now VUX, V is for vertical, that's up and down. U is the slope, it's undefined, I'll say UND. The equation is x equals a number. So the equation for this vertical line is x equals -2. Now they're not asking for the equation in this problem, they only want slope. So for line D, the slope is 0, horizontal is 0, vertical line, the slope is undefined. But if you wanted the equation, you could do that. Okay, so if you have the picture, we can count rise and run. But there's also a formula for this, and the formula, m equals y2 minus y1 over x2 minus x1. And again, now it's subtraction, rise over run, it's the difference in the y's divided by the difference in the x's. In physics, you may see something like this. That little triangle means change. The change in y divided by the change in x. And because it's a difference, that's why we're subtracting. So it's y2 minus y1 over x2 minus x1. Now, you can actually sing the formula. If you're familiar with the nursery rhyme, row, row your boat, and, row, row, row your boat gently down the stream, merrily, 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 life is but a dream. We can actually sing the slope formula. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. All right, so the way you could use that, let's do some examples. Let's take number 3. So we have 2 points. We're going to calculate the slope of this line that goes through there. X sub 1, y sub 1, excuse me, x sub 1, y sub 1, x sub 2, y sub 2. So for the slope, we're going to subtract the x's. So I'm going to do y sub 2 minus y sub 1, 10 minus 3, over x sub 2 minus x sub 1. Some of you may ask, well, wait a minute, can I do y sub 1 minus y sub 2? Yes, as long as you do x sub 1 minus x sub 2. You have to go the same way. You have to be consistent. And this gives us 7 over 5. And that's it. You can't simplify that, you're done. X sub 1, y sub 1, x sub 2, y sub 2. All right, let's sing it. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now notice I am subtracting. It's always subtraction with slope, but because there's a negative, I'm subtracting a negative. So I can simplify that. That will both become positives. That becomes 6 plus 2. And what we get is negative 2 over 8, which reduces to negative 1 over 4. So your slope is negative 1/4. Now, when you have a negative fraction, you can write the negative in the top of the fraction. You can write it out front. You can, sometimes you may end up with a negative in the bottom, in the denominator. We don't leave it like that. We'll write it here this way or this way, okay? So you've got really kind of 3 ways, but we'll do it one of these 2 ways here. X sub 1, y sub 1, x sub 2, y sub 2. So this is our first xy ordered pair and our second xy ordered pair. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now again, we're subtracting a negative, and in this case, minus a minus becomes plus. Negative 1 plus 1 is 0. 5 minus 8 is negative 3. 0 divided by anything is 0. Sometimes people get confused, is that 0 or is it undefined? One thing you can do is type on a calculator and it will say 0 or give you some kind of error. But also, if you think about graphing this, if the y values are the same, 8, negative 1 is here. I'm just approximating. 5, -1 is there. Oh, that's horizontal. Hoi vux. Horizontal is a 0 slope. Okay. Now, that's all review. These are things that you've seen in Algebra 1 and probably before that. But let's talk about parallel versus perpendicular lines. So directions, calculate the slopes of all 3 lines. What do you notice about the slopes? Well, E and F are parallel. Okay, I'm just going to tell you that they are parallel lines. They look parallel, but they actually are parallel. If we count the slope for line E, we're going to rise 2 and run 1, 2, 3. So the slope of line E is 2/3. Notice the slope of line F, rise 2, run 1, 2, 3. Notice the slope of line F is also 2/3. Parallel lines are going to have equal slopes. And this should make some sense because parallel lines are going to move in the same direction in the same way, and they're never going to cross. So for that to happen, they're going to need to have the same rise and run so that they're moving the exact same way. So parallel lines will have equal slopes. Now, line G, I'm going to tell you, is perpendicular. I'm going to put a right angle there to both of these. This is obviously not the same slope. Now, if I count this, I'm going to go down 1, 2, 3, that's negative. And I'm going to go right 1, 2, that's positive. So the slope of line G is -3/2. Now I can say that line G is perpendicular to line E as well as perpendicular to line F. It's going to be perpendicular to both. Notice the difference in the slopes. Parallel lines, same slope. Perpendicular lines, this is what we call opposite reciprocals. Reciprocal is where you take the fraction and you flip it. So 2/3 becomes 3/2, and we take the opposite of that. So reciprocal is where you flip the fraction, and the opposite is where you take, if it's a positive slope, it becomes negative, and if it was negative, it becomes positive. So let's flip it on the back here and summarize this. The slopes of parallel lines are always equal. The first slope equals the second slope for parallel. But the slopes of perpendicular lines, which form 90-degree angles, right angles, are always opposite reciprocals. Opposite meaning positive and negative, and reciprocal meaning we flip that fraction. So m⁻1 equals the opposite of 1/m². That's how we would set that up. Now that may look a little confusing with the variables, so let's do some examples with actual numbers. Let's say the slope of a line is 5/2. Well, a parallel line would have the same slope, 5/2. Perpendicular would be the opposite reciprocal. So I flip this, and if it was a positive slope, now it becomes negative. And there we go. If the slope is -3/8, a parallel slope is equal, it's the same, -3/8. Perpendicular is to flip and take the opposite. Now, if it was a negative slope, that means it becomes positive. So -3/8 becomes 8/3 for perpendicular lines. Let's say it's an integer like 4. I'm going to write that as 4/1. Parallel line, same slope, 4 or 4/1. Perpendicular, I flip the fraction. That's why I put the 1 there. When I take the reciprocal, it's 1/4. If the slope was positive, now it's negative. And the last one, if you have a 0 slope, that's horizontal. So a parallel line is also 0. But a perpendicular line, which is vertical, hoi vux, VUX, oh, slope is undefined. And that's the end of part 1.